Under this topic, let us understand the comparison of 5G network functions with 4G nodes. Let's understand the comparison between the 5G nodes with 4G nodes first. It will help you correlate the network functions with older technology while studying it in later parts of the course. As we can see from table on the screen, EMF works as a part of MME from 4G core. It is responsible for mobility management. It makes the NAS signaling connection with user equipment and helps user equipment to register. HSS is turned into both AUSF and UDM. UDM sends the authentication vector to AUSF in order to make the subscriber authentication during registration. In 4G, this was held by HSS. Some part of MME is turned into SMF, which provides the session management functionality of it. In addition to this, it also combines some control plane functions of the SGW and PGW. SMF also does the job of giving IP to user equipments. UPF has some roles of SGW and PGW. SGW and PGW was responsible for data traffic and UPF does this traffic transport, which is done by these two. Data traffic comes from UE to G node B to UPF. Therefore, UPF can be called as gateway for internet or other networks. Subscriber authentication during registration or re-registration with 5G is managed by the authentication server function AUSF, which obtains authentication vectors from the UDM. Together they represents the functionality of HSS in 4G core. Application function AF is same as the AF in 4G core. NSSF is a new core network function in 5G. Its main functionality is to provide a required virtual slice of RAN, core and transport networks. In the future, operators will build some specific network slices depends on some requirements and NSSF function will have the information about these different network slices, including their definitions, resources, etc. UE may be able to ask operator to register different slice of a network and it will be able to request this while registering to the network. At this point, NSSF will just provide the information and functionalities of slices, but it will not authorize the UE. AMF will be responsible on this issue to authorize UE depending on the subscription information, which will come from UDM. UDM is responsible for generating the authentication vectors. They are requested by AUSF, which is similar to one MME. However, he does this using the subscriber profiles that are stored in UDR. UDR is like a database to store subscriber information, application-specific data, and policy data. Policy control is similar to one in 4G core network, but this time it is controlled by PCF, and PCF has some extra and new functions compared to PCRF, which is in 4G. AMF asks PCF for getting the access and mobility policies. One of the new functionality of PCF is to make resource reservation for the other services using HTTP or XML based interface. Network exposure function NEF and network function repository function NRF are new functions introduced in 5G. Our next topic is access and mobility management function AMF. The AMF is a control plane function within the 5G core network. The primary responsibilities of the AMF includes: first, registration management; second, connection management; third, reachability management; fourth, mobility management. It works as a part of MME from 4G core. Registration management allows a UE to register and deregister with the 5G system. A UE must complete the registration procedure to receive authorization to use 5G services. Registration moves the UE from the RMD register state to the RM register state. Registration creates a UE context within the network. A UE context is a set of parameters which identify and characterize the UE. Some of the parameters belonging to a UE context are presented in a figure shown on the screen. The AMF interacts with other network functions during the registration procedure. For example, the AMF forwards the permanent equipment identifier PEI to the SMF, UDM and PCF. Connection management is used to establish and release the control plane signaling connection between the UE and the AMF, that is, across the N1 interface. Establishing an N1 signaling connection moves the UE from CM idle to CM connected. The N1 signaling connection allows non-access stratum NAS message to be exchanged between the UE and the AMF. The AMF is the termination point within the core network for the integrity protection and ciphering applied to NAS messages. The termination point for NAS signaling procedures can either the AMF or the SMF. Reachability management is used to ensure that a UE is always reachable. That is, it is possible to page the UE when there is a requirement to establish a mobile terminated connection. Paging a UE which is in the CM idle state triggers the UE to initiate the NAS service request procedure and subsequently establish an N1 signaling connection before moving into the CM connected state. The AMF supports reachability management by storing location information as part of the UE context. The UE context includes the registration area, a tracking area or a list of tracking areas within which the UE is registered. The UE context can also include more specific information regarding the UE location, that is, recommended cells and nodes for paging. UE which are configured to use mobile initiated connection only MICO are categorized as being unreachable. These UE cannot be paged and are only able to establish mobile originated connections from the CM idle state. Mobility management is used to maintain knowledge of the UE's location within the network. The UE is required to complete periodic registration updates after it has completed initial registration. These periodic updates act as keep alive to verify that the UE remains on the system and has not moved out of coverage or become unavailable due to any other reason. Example, the battery has drained. The UE is also required to complete updates due to mobility. These upgrades are triggered if the UE moves outside the current registration area, that is, outside the tracking area or list of tracking areas within which the UE is currently registered. The AMF is also responsible for handling Next Generation Application Protocol (NGAP) signaling, which is transferred between the AMF and a Next Generation RAN mode, that is, between an AMF and a base station. NGAP is equivalent to S1 AP, which is used in 4G networks between the MME and base station. Categories of NGAP signaling procedures include PDU session management, UE context management, UE mobility management, paging procedures, transport of NAS messages, interface management, configuration transfer, warning message transmission. PDU session management procedures are used to set up, modify, and release resources at the base station and UE. The SMF is responsible for PDU session management, so these procedures are completed after the AMF has been instructed by the SMF. UE mobility management procedures are used to support handover procedures. XN-based handover procedures use the NGAP path switch signaling procedure. The XN interconnects a pair of 5G BTS similar to the X2 interface used by 4G. N2-based handover warning message transmission procedures use the N-gap handover required, handover request, handover command, and handover notify signaling procedures. N-gap is used to transfer NAS messages between the BTS and AMF, while a signaling radio bearer (SRB) is used to transfer NAS messages between the UE and BTS. The combination of these hops provide the end-to-end transfer of NAS messages across the N1 interface between the UE and AMF. The combination of NAS and N-gap signaling is shown in the figure on screen. This figure also illustrates a subset of NAS messages being transferred to and from the SMF. Interface management procedures are used to set up the NG connection between the base station and AMF. Both the N1 and N2 interfaces uses the NG connection between the base station and AMF. Interface management procedures also allow both RAN and AMF configuration updates to be provided. For example, the RAN configuration update allows the base station to inform the AMF of any changes to the supported PLMN and tracking areas. Configuration transfer procedures allow the base station and AMF to exchange information related to self-optimization networks (SON). For example, these procedures can be used to support automatic neighbor relations. The end-to-end transfer of information could be between a pair of base stations, but the information has to be sent via the AMF if an XN interface does not exist between the base stations. The AMF is responsible for allocating a 5G globally unique temporary identifier, which is a concatenation of the globally unique AMF identifier and the 5G temporary mobile subscription identifier 5G TMSI. The 5G GUTI provides greater privacy than the IMSI because it is a temporary ID entity which the AMF can reassign at any time. 3GPP has specified mapping rules between the 5G GUTI and the 4G GUTI. This includes a mapping between the AMF identity and the MME identity. The 5G TMSI is mapped onto the 4G MTMSI. The AMF is responsible for selecting an appropriate authentication server function AUSF during the registration procedure. The AUSF allows the UE to authenticate itself with the 5G core network, that is, verify that the subscriber is genuine and authorized to access the network. The AMF may be configured to use a specific AUSF, or the AMF may use the Network Repository Function NRF to discover suitable AUSF within the 5G core network. The AMF is responsible for selecting an appropriate Unified Data Management UDM function during registration procedure. The UDM manages the user's subscription information. The AMF may be configured to use a specific UDM, or the AMF may use the Network Function Repository function to discover a UDM which manages the user's subscription. The AMF is responsible for selecting an appropriate policy control function PCF for the UE during the registration procedure. The PCF provides the AMF with an access and mobility policy for the UE. This may include a specification of allowed or forbidden tracking areas. The AMF may be configured to use a specific PCF, or the AMF may use the Network Function Repository function to discover the PCF which can provide the relevant UE information. The AMF is responsible for selecting an appropriate session management function during PDU session establishment. The AMF can apply a range of criteria during the selection procedure. First, Data Network Name (DNN). A DNN is the 5G equivalent of a 4G access point name (APN). It refers to the data network to which the PDU session provides connectivity. For example, there may be a DNN for connectivity towards the public internet. A specific SMF may be configured to support a specific set of DNN. Second, subscription information. The AMF retrieves subscription information from the Unified Management (UDM) function during the registration procedure. This can include information regarding the set of subscribed DNN. Third, Single Network Slice Selection Association information. An SNSSAI identifies a network slice. It comprises a slice or service type SST and a slice differentiator SD. The SST defines the expected network behavior. For example, value 1 refers to enhanced mobile broadband EMBB and value 2 refers to ultra reliable low latency communication URLLC. The SD allows differentiation of services belonging to the same SST. The AMF provides support for the short message service. Mobile terminated SMS are received from the SMS function and are packaged within a NAS message before being transferred to the UE. A signaling radio bearer SRB is used to transfer the NAS message across the air interface. The AMF receives mobile originated SMS within uplink NAS messages and forward them to SMSF. The SMSF is an optional network function. Here I conclude Network Slice Selection Function NSSF. The Network Slice Selection Function is a control plane function within the 5G core network. The NSSF is connected to the access and mobility management function using the N22 reference point. The AMF can request the NSSF to complete network slice selection during the UE registration procedure. It is a new function introduced in 5G and does not have any similar node in 4G. A single network slice is identified by its single network slice selection assistance information. A set of one or more network slices is identified by its network slice selection assistant information. The AMF can provide the NSSF with the following information. First, requested NSSAI generated by the UE from the allowed and or configured NSSAI. Second, the mapping from requested NSSAI for the serving PLMN to configured NSSAI for the home PLMN. Third, subscribed SNSSAI with an indication of any default SNSSAI. Next is identity of the UE's home PLMN. Next is identity of the UE's current tracking area. The NSSF uses the information provided by the AMF to first verify that UE is subscribed to each of the SNSSAI belonging to the requested NSSAI. Second, select one or more network slices to serve the UE and generate the allotted NSSAI. Next is identify a set of candidate AMF which can be used to serve the UE. If the NSSF determines that the current serving AMF is unable to support the selected NSSAI, then an AMF relocation is initiated. That is, the NAS registration request is rerouted to a new AMF. The NSSF may also select the network function repository function, which can be used to select other network functions within the selected network slice. Our next topic is application function AF. Let's see what's there in this topic. The AF is a control plane function within the 5G core network. The application function acts as an application server providing support for specific services. For example, there could be an application function for a video streaming service. Application function AF in 5G core is similar to one that was there in 4G. Application functions with direct access to the 5G core network are connected to the PCF using the N5 reference point. If an application function does not have direct access to the 5G core network, then it can use the network exposure function to provide connectivity. Third-party application functions may be untrusted and be required to use the NEF. Application functions are able to influence user plane function selection and also traffic routing towards specific data networks. Application functions send requests to the PCF. The PCF can translate those requests into policies for specific PDU sessions. The policies are subsequently provided to the session management function. An application function and user plane function may be co-cited with the PTS when deploying multiple access edge computing. MEC provides the benefit of keeping the service content physically close to the access network. This reduces latency and also helps to reduce the requirement for transport bandwidth. The MEC application function interacts with the PCF to request that the SMF selects the MEC UPF for the appropriate PDU sessions and also that those POU sessions are routed towards a local content server. Application functions are already used within the 4G network architecture when using an IP multimedia subsystem to support Voice over LTE, also known as VoLTE. In that case, the proxy call session control function acts as an application function for the voice service. Our next topic is network exposure function, NEF. The network exposure function is a control plane function within the 5G core network. It is a new function introduced in 5G and doesn't have any similar node to 4G. The NEF is able to provide information regarding the capability of network functions within the 5G system to external network functions, that is, it is able to expose certain network capabilities. For example, the NEF is able to expose the network monitoring capabilities. This allows the external network function to subscribe to the reporting of specific events. Network functions within the 5G system are able to report specific events to the NEF. The NEF can then provide reports of those events to other functions. Example events include: first, loss of connectivity for a specific UE reported by the AMF. Second, location information for a specific UE reported by the AMF. Third, a change in the relationship between subscription permanent identifier and permanent equipment identifier. An end user moves a USIM from one device to another reported by the UDM. Fourth, roaming status for a specific UE reported by the UDM. Here the figure on the screen illustrates the signaling used by a network function when subscribing to a specific event. The network function sends a subscriber request to the NEF. The NEF then has to subscribe to receive reports from the relevant network function. In this example, it is assumed that the UDM is providing the reports. Once the subscription procedure is complete, the UDM will start to send reports to the NEF, which can then be forwarded towards the network function which have subscribed. The NEF supports event exposure towards network function within the 5G system and also towards network function located outside the 5G system, that is, external network functions. For example, an external application could collect statistics regarding the location of devices. The NEF is responsible for masking network and user-sensitive information when reporting to external network functions. Example, UE identifiers are likely to be masked to protect privacy. The NEF is also able to expose the network provisioning capability. This allows external network function to identify the information which can be provisional for UE belonging to the 5G system. The NEF forwards any provisioning information onto the UDM where it is stored as a part of the UE profile. The type of information which can be provisioned is the expected UE behavior in terms of its movement and communication characteristics. The information can be accessed by other network functions within the 5G system to help configure mobility management or session management parameters. The NEF is also able to expose the policy or charging capabilities of the network. This allows external network function to influence the QoS and charging policy for specific UE. For example, the priority and charging rate for a specific UE can be influenced. The NEF stores its data using a unified data repository. The data is stored as structured data using a defined format. Our next topic is Network Function Repository Function, NRF. The Network Function Repository Function is a control plane function within the 5G core network. It is a new function introduced in 5G and doesn't have any similar node in 4G. The NRF allows network functions to register their services and then allows other network functions to discover those services. That is, the general pattern is network function service registration followed by network function service discovery. These general procedures are illustrated in above figure. Network functions are expected to complete the service registration procedure when they first become active in the network. Network functions provide a list of their services in addition to their network function type and contact details, that is, an IP address or fully qualified domain name. Network functions attempting the service discovery procedure provide the NRF with the name of the service being sought and the target network function type. The NRF is responsible for authorizing requests. Some network functions may be configured such that they can only be discovered by other network functions belonging to the same network slice. Here I conclude. Our next topic is Policy Control Function, PCF. The PCF is a control plane function within the 5G core network. It is responsible for providing policies associated with mobility management and policies associated with session management. Mobility management policies can impact UE mobility in both RRC idle and RRC connected modes. Session management policies impact the quality of service offered by the PDU session. Session management policies also offer a mechanism to manage subscriber spending limits. PCF was called PCRF in 4G. The general pattern of interaction between the AMF, UDM and PCF is illustrated in the figure on the screen. The AMF obtains subscription information from the UDM. The UDM may store this information locally or may need to retrieve it from the UDR. The AMF subsequently provides the subscription information to the PCF. The PCF stores the subscription information either locally or using UDR. The PCF may then decide to modify the subscribed policy information according to the operator policies. For example, the subscribed policy from the UDM may not include any access restrictions. The operator policy configured within the PCF may specify that the UE is not permitted to access a specific TAC during business hours. In that case, the PCF would modify the subscribed policy during business hours and would provide the modified policy to the AMF. The general pattern illustrated in the figure is applicable to the access and mobility policy, which the AMF retrieves from the UDM during the UE registration procedure. The access and mobility policy allows a definition of service area restrictions. The UE is responsible for applying restrictions in the CM idle or RRC idle and CM connected or RRC inactive states. In this case, the network provides a UE with the relevant service area restrictions. Example, a list of forbidden tracking areas. Service area restrictions can be signaled to the UE using a NAS, registration accept message. The network is responsible for applying restrictions when the UE is in the CM connected or RRC connected state. In this case, The network can apply handover restriction lists to prevent specific mobility paths. It is also applicable to the RAT or frequency selection priority. The RFSP is an index which is provided to the base station and is then used to select specific radio resource management strategies. For example, the RFSP can be used to determine the set of cell reselection priorities provided to a UE. Alternatively, it may be used to move RRC connected mode UE to a specific network layer. Similarly to the access and mobility policy, the AMF retrieves the subscribed RFSP from the UDM during the UE registration procedure. It is subsequently provided to the PCF where it can be modified according to an operator policy. RFSP is equivalent to the subscriber policy identity used by the 4G networks. The PCF can define an access network discovery and selection policy. The UE uses this policy for selecting non-3GPP access networks, for example, a wireless local area network WLAN based upon Wi-Fi. The non-3GPP access network can be used to offload traffic from the 3GPP access network. The UE can be provided with a WLAN selection policy which specifies the condition under which the UE should search for a WLAN and the set of selection criteria, for example, the maximum WLAN load and a list of service set identifiers. The PCF can define a UE route selection policy which provides a UE with routing outgoing traffic. The rules can indicate the traffic should be routed to an existing PDU session, or that a new PDU session should be established, or that traffic should be offloaded to a non-3GPP access network. The URSP include a set of traffic descriptors which allows the UE to recognize a specific type of traffic, for example, destination IP address, destination port number, and higher layer protocol identity. The URSP also includes a set of route selection descriptor to indicate where the traffic should be routed, for example, a specific data network name, DNN. The PCF can retrieve information regarding the load of a network slice from a network data analytics function. The NWDAF is an optional network function which can collect network slice load statistics without having knowledge of specific subscribers. The PCF can use the load information when generating its policies. An application function AF may contact the PCF to request a time window for background data traffic. For example, if a large number of UE requires a software update, then the download of the software can be treated as background data traffic. The request includes the quantity of data to be transferred and the expected quantity of UE. The PCF can respond with a recommended time window, a corresponding charging rate, and a maximum bit rate. The PCF interacts with the SMF during the establishment of a PDU session. The SMF retrieves QoS parameters from the Unified Data Management Network function. These parameters include the default SQI, the default allocation and retention priority, and the subscribed session aggregate maximum bitrate. The SMF subsequently provides this information to the PCF. The PCF applies its policy-making decisions to generate the authorized SQI, ARP, and session AMBR. These authorized parameters are then returned to the SMF. The SMF forwards the parameters to the relevant network functions for enforcement. Example, they are forwarded to the user plane function, UPF. The PCF provides the SMF with service data flow, SDF templates. The SMF forwards the SDF templates to the user plane function, which uses them to map downlink packets arriving from the external data network onto specific QoS flows belonging to specific PDU sessions. The PCF provides the SMF with charging rules. These rules can be based upon data volume, time, or specific events. Charging rules can also indicate that charging should not be applied. The PCF helps to enforce subscriber spending limits using information provided by the online charging system. The OCS is connected to the PCF using N28 reference point when using reference point system architecture. The OCS tracks the current subscriber spending and provides spending limit reports to the PCF. The PCF can provide traffic steering rules to the SMF. The SMF forwards these rules to the user plane function where they are used to select an appropriate N6 interface towards the external data network. For example, traffic steering can be used to direct traffic belonging to a specific PDU session through a parental control path to help ensure that any content being accessed is appropriate. Our next topic is Session Management Function, SMF. Let's get into the topic. The SMF is a control plane function within the 5G core network. The primary responsibilities of the SMF include: first, PDU session management; second, IP address allocation; third, GTPU tunnel management; fourth, downlink notification management. It also has the sum as a part of MME functions when compared to 4G core. PDU session management includes the setup, modification, and release of PDU sessions. A PDU session is the 5G equivalent of an EPS bearer in 4G. It represents a connection between the UE and the exit of a user plane function, UPF, towards a specific data network, DN. The exit is identified by its data network name, DNN. Here the figure on the screen shows the concept of PDU session and the DNN providing connectivity to the specific data network. PDU session management requires the SMF to complete signaling procedures towards the UE, base station, and user plane function, UPF. The SMF can signal directly with the UPF but requires the AMF to support signaling towards the UE and base station. The SMF uses non-access stratum NAS signaling messages to communicate with the UE. Both the base station and AMF act as transparent routers for these messages, which are relayed between the SMF and UE. The UE can initiate the setup of a PDU session by sending a NAS PDU session establishment request. Assuming a successful setup, the SMF responds with a NAS PDU session establishment accept or message. Signaling towards the base station requires the AMF to transfer messages using the next generation application protocol, NGAP. The AMF and base station are responsible for managing NGAP signaling procedures, but content is relayed to and from the SMF when those procedures relate to session management. IP address allocation is dependent upon the type of PDU session. A PDU session can be set up to transfer either IPv4, IPv6, Ethernet, or unstructured data types. The UE can request a specific data type within the NAS PDU session establishment request message. The allocated data type is confirmed within the NAS PDU session establishment accept message. IP address allocation is applicable to PDU sessions which transfer IPv4 or IPv6 packets. The IP address defines the network layer source address for uplink packets and destination address for downlink packets. The 3GPP specifications also allow the UE to request the use of Dynamic Host Configuration Protocol DHCP to obtain an IP address. In this case, the SMF does not allocate an address and instead the UE uses the connectivity provided by the PDU session to obtain an IP address from a DHCP server. GTPU tunnel management refers to the management of the user plane GTPU tunnel between the base station and UPF. GTPU tunnels are used to transfer user plane data between the base station and UPF. A GTPU tunnel operates by adding a set of IP or UDP or GTPU headers to the user plane data packets. The IP layer is used to route the packets between the base station and UPF. The UDP layer is used to provide connectionless data transfer and to specify the port number for the GTPU layer. The GTPU layer specifies the tunnel endpoint identifier TEID, which links the user plane packet to a specific PDU session. The general concept of a GTPU tunnel is illustrated in second figure. The UPF allocates a tunnel endpoint identifier TEID for uplink data transfer. The base station addresses all uplink data belonging to the relevant PDU session towards that TEID. The TEID is signaled from the UPF to the base station via the SMF and AMF. Similarly, the base station allocates a TEID for downlink data transfer. This TEID is signaled to the UPF via the AMF and SMF. Downlink notification management refers to the initiation of the paging procedure. A UE needs to be paged if downlink data arrives at the UPF after the UE has been released to RRC idle mode, CM idle state. The UPF recognizes that the UE does not have a GTPU tunnel towards the base station. This triggers the UPF to inform the SMF that downlink data has arrived for the UE. The SMF subsequently informs the AMF from where the network triggered service request procedures is initiated, that is, the UE is paged. This triggers the UE to establish an RRC connection and send a NAS service request message to the SMF. The SMF is responsible for selecting an appropriate UPF during the setup of a PDU session. The selection algorithm can account for UPF load, geographic location, network slicing, supported features and PDU session type, that is IPv4, IPv6, Ethernet, unstructured. Load information can help the SMF to balance network load across multiple UPF. The geographic location can be important for low latency applications which require a short transport connection to data network. It may be necessary to account for network slicing if different UPF are configured to support different slice or service types SST. For example, one UPF may be configured to support enhanced mobile broadband EMBB, while another UPF may be configured to support ultra-reliable low-latency communication URLLC. The SMF is responsible for selecting an appropriate policy control function PCF during the setup of a PDU session. That is, it selects the PCF to provide the policy for a specific PDU session. The AMF selects the PCF during a UE registration procedure to obtain the access and mobility policy. For example, set of forbidden tracking areas. The PCF associated with the PDU session provides a policy for the quality of service QoS. Example, the authorized 5QI allocation and retention policy ARP and session aggregate maximum bit rate session AMBR. The selection algorithm can account for the PCF already selected by the AMF, the data network name DNN used by the PDU session or information configured within the SMF. For example, an SMF may be configured to use a specific PCF. The SMF retrieves subscription information from the Unified Data Management UDM function during the setup of a POU session. The information retrieved can include authorized PDU type, TPv4, FPv6, Ethernet, unstructured. Default 5QI, default allocation and retention priority, ARP, session aggregate maximum bitrate, session AMBR, and authorized session and service continuity SSC. SSC refers to the preservation of connectivity and IP address allocation throughout the lifetime of a POU session. For example, ensuring that service connectivity is maintained when changing the VPF, which provides the data network connection. The SMF provides support for interfacing with the network charging system. This could be either an online charging system OCS or an offline charging system OFCS. An online charging system involves the authorization of data transfer before it is transferred. For example, for a prepaid mobile broadband subscription. An offline charging system allows data to be transferred and billed at a later time. Data utilization measurements are completed by the UPF. The SMF is able to configure those measurements and also collect the resultant reports from the UPF. The SMF then provides the report to the charging system. Here I conclude. Our next topic is Unified Data Management, UDM. The UDM is a control plane function within the 5G core network. It is similar to the Home Subscriber Server HSS within the 4G Evolved Packet Core EPC. AUSF and UDM together represent the functionality of HSS from 4G core. The UDM manages subscriber data and may also store subscriber data. The subscriber data can be stored locally within a UDM or it can be stored within a unified data repository. The latter solution allows multiple UDM to access the subscriber data from a central storage location. The subscription permanent identifier is managed by the UDM. 3GPP devices uses their International Mobile Subscriber Identity IMSI as the SUPI. Non-3GPP devices can use their Network Access Identifier NAI as the SUPI. The UDM interacts with the AUSF during the authentication procedure. The AUSF provides the UDM with either the SUPI or the Subscription Concealed Identifier. The SUCI is a privacy-preserving identifier which contains the SUPI. If the UDM receives a SUCI, then it extracts the SUPI before proceeding. The UDM uses the SUPI to select an authentication method based upon the end-user subscription profile. The UDM then generates an authentication vector and sends this vector to the AUSF. The UDM interacts with the AMF during the registration procedure. The UDM stores or uses a UDR to store the AMF identity for the UE, which is completing the registration procedure. Storing the AMF identity allows the UDM to support UE reachability procedures. The UDM provides the AMF with access and mobility subscription data and also subscription data to support the selection of an SMF. The UDM interacts with the SMF during the PDU session establishment procedure. UDM stores or uses a UDRs to store the PDU session identity, the SUPI, the SMF identity, the SMF address, and data network name DNN. The UDM provides the SMF with subscription information which can include authorized PDU type, that is IPv4, IPv6, Ethernet, unstructured. Default 5QI, default allocation and retention priority, session aggregate maximum bitrate, authorized session and service continuity. The UDM can provide updates to the AMF and SMF if subscriber data is changed. The AMF can be updated if the access and mobility subscription data is changed, whereas the SMF can be updated if the session management subscription data is changed. The UDM is required when sending SMS over non-access stratum signaling messages. The SMS function selects the registers with a UDM during the UE registration procedure. The UDM stores or uses a UDR to store the SMSF identity for the UE which is completing the registration procedure. The UDM provides the SMSF with relevant subscription information. The SMS Gateway Mobile Switching Center contacts the UDM when sending a mobile terminating SMS. The UDM provides the SMS GMSC with the identity of the relevant SMSF to which the SMS can be forwarded. Our next topic is Unified Data Repository (UDR). The Unified Data Repository is used to store data belonging to the Unified Data Management, Network Function, Policy Control Function, and Network Exposure Function. That is, the UDR is able to store first, subscription data which can be retrieved by a UDM. Second, policy data which can be retrieved by the PCF. Third, structured data which can be retrieved and exposed by an NEF. Structured data refers to data which has a known and organized format. Within the context of the NEF, it refers to records of events which have occurred. For example, the AMF may detect a loss of connectivity towards a specific UE. This event can be stored by the UDR and subsequently retrieved and exposed to other network functions by the NEF. Here the figure on the screen illustrates the general connection of a UDR to an NEF, PCF and UDM. Other network functions use a UDSF rather than a UDR to store their data. The UDR can be implemented to be dedicated to a specific network function rather than shared by the UDM, PCF and NEF. For example, a UDM implementation may include a UDR which only serves that UDM. Similarly, a PCF implementation may include a UDR which only serves that PCF. Our next topic is Unstructured Data Storage Function (UDSF). Let's get into the topic. The UDSF is used to store data belonging to other network functions. For example, an AMF may use a UDSF to store the UE contexts that are being managed at that point in time. Network functions may have their own UDSF or they may share a common UDSF. Here the first figure on the screen illustrates the general connection of a UDSF to another network function. Storing data within a UDSF at a central location helps to allow network functions to operate in a stateless manner. Stateless operation means that network functions do not rely upon making transitions between states. Instead, every transaction is treated as a new transaction. If a network includes multiple instances for a specific network function, then stateless operation allows one instance of the network function to take over from another without needing to transfer any information regarding the current state. The other figure illustrates an example of stateless operation when an AMF experiences outage. This example assumes a first AMF which is managing UE A and B and a second AMF which is managing UE C. Both AMF share a common UDSF, so both have access to all UE context data. If AMF1 experiences outage, then AMF2 can immediately access the data for UE A and B. This prevents UE context data being lost when AMF1 experiences outage and allows a relative seamless continuation of services. Here I conclude this plane function, UPF. The user plane function is responsible for routing and forwarding user plane packets between the base station and the external data network. When compared to 4G core, it performs the sum role of SGW and PGW. Uplink packets arriving from the base station use a GTP U tunnel to reach the UPF. The UPF has to remove the packet headers belonging to the GTP U tunnel before forwarding the packets into the external data network. The UPF may provide connectivity towards multiple data networks, so the UPF has to ensure that packets are forwarded towards the correct network. Each GTPU tunnel belongs to a specific PDU session, and each PDU session is set up towards a specific data network name. The DNN identifies the external network to which plain packets should be forwarded. Thus, the UPF has to keep a record of the mapping between GTPU tunnel, PDU session, and DNN. Downlink packets arriving from the external data network must be mapped onto specific QoS flows belonging to specific PDU sessions before forwarding towards the appropriate base station. A QoS flow corresponds to a stream of packets which have equal QoS. A PDU session can have multiple QoS flows. The UPF uses a set of SDF templates to map each downlink packet onto a specific QoS flow. SDF templates provide a set of rules for this mapping process. For example, the following parameter combination, source IP address X, destination IP address Y, source port number J, destination port number K, should be mapped onto QoS flow, A belonging to PDU session. The concept of mapping packets onto QoS flows using SDF templates is illustrated in the figure on the screen. After identifying the appropriate QoS flow, the UPF forwards the packet across the GTPU tunnel belonging to the parent PDU session. There is one GTPU tunnel per PDU session rather than one GTPU tunnel per QoS flow. The UPF marks the GTPU header to indicate the QoS flow associated with each packet. That is, the QoS flow identity QFI is included within the GTPU header. The UPF receives the set of SDF templates from the session management function SMF during the setup of the PDU session. The SMF generates them from information provided by the policy control function PCF. The UPF also verifies that the SDAP layer within the 5G BTS is applying the correct mapping between uplink data packets and QoS flow. That is, the UPF inspects the uplink packets to confirm that the correct mapping has been applied according to the set of SDF templates. The UPF can prioritize the packets being transferred across the transport network by marking them within the IP header belonging to the GTPU tunnel. That is, the outer IP header added by the UPF rather than the inner IP header which belongs to the end user application, assuming a PDU session has been set up to transfer IP packets. The Differentiated Services Code Point DSCP field within the IP header can be used for this purpose. The UPF is responsible for notifying the SMF when downlink data arrives for a UE which is in the CM idle state. That is, the UE needs to be paged before the data can be forwarded across the N3 interface towards the base station. The downlink data is buffered by the UPF while waiting for the UE to establish its connection and move into the CM connected state. The UPF is responsible for enforcing the session aggregate maximum bit rate, which defines the maximum permitted bit rate summed across all non-GBR QoS flows belonging to a specific PDU session. The UPF receives the session AMBR from the SMF during the setup of the PDU session. The SMF obtains it from the policy control function PCF. The UPF is responsible for tracking the volume of data transferred by each PDU session and reporting this information to the SMF. The SMF provides these reports to the charging system for billing purposes. The UPF acts as an anchor point for mobility procedures which do not involve a change of UPF. In general, the majority of XN based handovers and N2 based handovers will not require the UPF to be changed. In these cases, the data path is simply switched from the source base station to the target base station. Multiple UPF can be used to support multi-homed PDU sessions. A multi-homed PDU session is one which has more than a single anchor UPF providing data network connectivity. For example, a POU session can have a single branching point UPF providing connectivity towards a base station combined with two anchor UPF providing a pair of interfaces towards the external data network. This type of architecture is shown in the figure on the screen. Multi-homed connections can be used to provide redundancy and increase system reliability. Our next topic is Authorization Server Function AUSF. The AUSF is a control plane function within the 5G core network. Its primary function is to support both subscriber and network authentication, that is, the network verifies that the UE is a genuine authorized subscriber while the UE verifies that the network is genuine. AUSF and UDM together represents the functionality of HSS from 4G core. The AMF can call upon the AUSF to support authentication during the EU registration procedure. Similarly, the AMF can call upon the AUSF to support authentication during any other procedure which involves establishing a signaling connection within the UE. For example, the service request procedure. The authentication procedure is completed between the UE and the AUSF. However, the AUSF cannot communicate directly with the UE. The AMF is used to relay information between the UE and AUSF. The AMF uses non-access stratum signaling towards the UE. Authentication is categorized as a mobility management NAS procedure. The 5G system supports the following authentication method: EAP, AKA, which is revised version of EAP, AKA. EAP is an acronym of Extensible Authentication Protocol, whereas AKA is an acronym for Authentication and Key Agreement. 5G AKA, which is revised version of EPS AKA. In addition to authenticating the UE, these procedures generate keys for subsequent security procedures. The AUSF uses the Unified Data Management function during the authentication procedure. Subscription information is managed by the UDM. The AUSF may be configured to use a specific UDM, or it may use the network function repository function to discover an appropriate UDM. Here I conclude this